Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is NASA's current asteroid missions. And here to give us all the information is John McGill. John, welcome to the program.
Yeah, hi, Don.
Great to have you back. All right, so NASA has 3 current missions. Where do we start?
Yeah, NASA dubs this past fall as Asteroid Autumn, and that was because of milestones on the 3 major asteroid missions. So let's start a little slideshow that I got put together. This is NASA's Asteroid Autumn, and it starts off with OSIRIS-REx and asteroid Bennu's return sample that occurred on September 24th. And then we had the Psyche launch that was on October 13th, and I was there for that one, so we'll have some stuff to talk about there and some pictures. And then Lucy's first asteroid flyby that happened on November 1st. So now we'll talk about OSIRIS-REx launch, and that happened on September 8th of 2016. And the Origin Spectral Interpretation Resource Identification and Security Regolith Explorer, or OSIRIS-REx for short, was a spacecraft that traveled to a near-Earth asteroid named Bennu and collected a sample of rocks and dust from the surface. And here in the upper left-hand corner, you can see what all that meant of how they got OSIRIS-REx again. But I'm not going to say it again. I lucked out getting it done the first time. But anyways, in this picture, you can see over here is the sample return capsule, or what they refer to as SRC. And then you have the suite of cameras and instruments. And then this long arm here, this is called this TAG SAM, or the touch and go sample arm. And this part down here is what actually went into the planet, and these holes in the side are what collected the rocks and the regolith from Bennu. And this is what Bennu looked like, and there was an interesting fact about this picture. And if you look at the picture, you can see some shiny white rocks on the surface. And what they determined about Bennu was it's just a rubble pile.
That's exactly what it looks like, yeah.
It's kind of like balls at McDonald's, where, in the play area they used to have, where you can jump in and you can fall through. And so that's what happened with the tag arm. When it hit Bennu, it went in pretty deep. But those white rocks, they determined that those were actually from the asteroid Vesta. So this is a collection of rocks from the whole solar system.
Interesting.
And here we have the SRC, or sample return capsule. And this is right after they grabbed the samples, and now they're stowing them in the sample return capsule for its trip back. So on the left, it's getting placed there by the arm, and then so now the picture on the right, there it's stored, and now it's just got to be covered up. And once it's covered, there's like screws that attach the top, so it's held tight. So it's sealed and airtight.
Okay. Now I notice at the bottom, why is that bottom part brown? It didn't appear that way before, as I recall.
Yeah, this part on the bottom, this is an ablative surface that they put on it. So what ablative surface is, that means that it kind of sheds as it comes through the atmosphere. So it absorbs the heat and sheds off the heat. And that's when you see the air ionized as it comes to Earth.
Oh, I see. Okay.
And here you can see it all black in there, and that's it returned, and this is the first U.S. mission to collect a sample from an asteroid, and it returned on September 24th, 2023. And it dropped off the material from asteroid Bennu. The spacecraft didn't land, but it continues on a new mission. And now it's called OSIRIS APEX, and it's going to go on to explore the asteroid Ophis in 2029.
Okay, yeah, I think it was the first U.S., but I think the first overall mission, as I recall, was the Japanese Hayabusa mission to Ryugu back about 4 years ago.
Yeah, that was, and they were successful. That was their second try. That's why it was called Hayabusa 2. And the first mission that they tried, Hayabusa 1, that one, the arm that collects the samples got damaged, and they weren't able to collect any samples except for what stuck on the craft. And when they came back, it got contaminated coming through the atmosphere. So,
sure.
Yeah, but Hayabusa 2, that one did produce about 5 grams of rocks for science. So they were the first.
Okay. So I guess next we have the Psyche mission.
Okay, yeah, let's talk about the Psyche mission. And this is a picture that I took in the media center, and this is where NASA holds its news conferences. So this was right before the news conference was started. And what is asteroid 16 Psyche? Well, it was discovered in 1852 by an Italian astronomer named Annabelle de Gasparis. And the number 16 denotes that it is the 16th minor planet in order of discovery. And, you know, we were talking about Vesta. Do you remember what number Vesta was?
Four, I think.
Yep, you got it. That was 4. And what's number 1?
Ceres.
There we go. That
Right.
was the first one discovered. And that was discovered a little before Psyche here, 16. So there was a lot of asteroids discovered in the 18th century.
Yes, indeed.
Okay, the largest known singular metal object in the solar system, and orbits the asteroid belt between Mars and Jupiter. In the Psyche makeup, let's see here. Okay, it was assumed to be mostly of metal, and recent data suggests 30 to 60% of its volume is metal. And other metal elements are either rock or silicate, think sand or glass, and it's the densest known asteroid.
So is this what makes...
And why is 16 Psyche special?
Exactly, that's what I was just wondering.
Well, yeah, what it is they believe that it was the inner core of a planetesimal. Planetesimal is just a big name for a small planet. And so it was a differentiated planetesimal, somewhat similar to Earth, meaning that it had different layers. So it had, you know, across the mantle and the solid core in the middle. And they believe that it was struck by an asteroid, another asteroid, and that blew all the rest of the layers off and just left the exposed solid inner core.
Okay, so...
So the science goals of this mission is to understand a previously unexplored building block of planet-forming iron cores and to look inside terrestrial planets, including Earth, by directly examining the interior of a differentiated body, which otherwise could not be seen, and to explore a new type of world for the first time, examine a world made not of rock and ice, but of metal.
Yeah, this will be an
now
interesting...
let's talk about the spacecraft.
Yeah, this will be an interesting sample to check out someday.
Oh yeah, let me go back to that that sample when if they do get it. This one basically it's just going to be cameras. They're not going to bring back a sample.
I see.
But it would be interesting to see if it would have those same patterns like metal asteroids have. I forgot what they call those terms, but it's like square patterns.
Oh, Wittgenstein patterns, yeah.
There you go. That's the name. I couldn't remember that one. We'd have to thank Sandra for that term.
Indeed.
Okay, we'll go back to the spacecraft now. So the size, the body of the solar panels are about the size of a singles tennis court, and the body is slightly bigger than a small van and the height of a basketball hoop, so about 10 feet tall. And here you can see some pictures of it. So I'd like to put pictures with people in it, so that way you can kind of get the dimensions of how big the craft is. If you look to the picture in the upper right there, you can see that's the SRC, or sample return capsule. And here it is again on the top here. In this picture, what's interesting here is these are 4 engines. These are the actual engines that are propelling this asteroid. And these are Hall effect thrusters. So that's something new, or not new, but these are the largest ones that NASA has put on any missions. And so at left, you see the xenon plasma emits a blue glow from an electric Hall thruster, identical to those that will propel NASA's Psyche spacecraft to the main asteroid belt. On the right is a similar, not operating thruster. And what this does is it uses the solar panels that collect the sun and it converts it to electricity. And then they put that together with the xenon, and then that creates extra electrons, and those get expelled, and that's the thrust.
Interesting.
Oh, so now we'll talk about some of the instruments. First, we got a multispectral imager. Then we got a gamma ray spectrometer and a neutron spectrometer, the magnetometer. And the magnetometer, they want to check out to see, being that it's a metal core, they want to find out if it has a magnetic field similar to how the Earth has a magnetic field. And then they have X-band radio telecommunication system, and that's run by the Deep Sky Network. So that's basically what all the spacecraft use right now to communicate back to Earth. And they have a new instrument on it. It's called the Deep Space Optical Communications Test. In that test, they're going to try using a laser to send optical communication. And they figure that doing it optically, because the bandwidth is so much tighter, they can get up to 100 times the amount of data in the same amount of time that it would take the X radio communication system.
Interesting. Interesting. Yeah, I remember with the mission to Pluto, it took a year to get all that data back. So this should speed that up quite a bit.
Yeah, and yeah, they want to especially get that going so that they can communicate quickly when they get to Mars and we start sending people to Mars.
Exactly.
And
exactly.
that mission was launched on October 13th, 2023, and that launched from Kennedy Space Center, riding a SpaceX Falcon Heavy rocket. And its expected arrival at asteroid Psyche is mid-2029. So the primary mission duration is going to be 26 months at the Psyche asteroid, and that's going to be orbiting there. And this is my picture of the Falcon Heavy launching the Psyche mission.
So, John, I understand there's an update about the Lucy mission.
Yeah, Don, what they were only supposed to go to 7 asteroids, and after they got the spacecraft up in the air and out into space, they decided there was a couple other objects that they were getting close to, and they thought that they were getting kind of anxious, so they wanted to test out some of their equipment. So they went to another asteroid, and that was called Dinkinish.
Right. Yeah, so, that wasn't part of the original mission, as I understand.
Right, that's what I'm saying. They added 4 more asteroid flybys. So this is the first one that actually is taking place. And what they determined was that Dinkinish is actually a binary system, and they kind of thought that because the magnitude kept oscillating back and forth, getting dimmer and darker. So that confirmed what they thought when they got close enough to see both objects.
If you have a question, please send us an email. The address is down there at the bottom of your screen. And we'll be right back after Term of the Month with Stephen.
Thanks, Don. The term of the month is Herbig-Haro. Herbig-Haro objects are bright patches of nebulosity associated with newborn stars. They are formed when narrow jets of gas ejected by stars collide with nearby clouds of gas and dust. They are commonly found in star-forming regions. This image of HH24 by HST shows two thin jets moving up and down from the bright source. Herbig-Haro objects are aligned with a young star's rotational axis. They are transient phenomena that last a few tens of thousands of years. Hubble Space Telescope observations have revealed the complex evolution of HH objects over a period of a few years. They are visible in near-infrared light, so ground-based observatories, Spitzer, the Hubble Space Telescope, and the James Webb Space Telescope have imaged them. This next image is from the James Webb Space Telescope near-infrared camera, and it shows HH797, which dominates the lower half of the image, going across the bottom of the image. It's located near the young open cluster IC348, which is located near the eastern edge of the Perseus dark cloud complex. The bright infrared objects in the upper portion of the image are thought to host two further protostars. Young stars are usually still embedded within gas and dust, but near-infrared light passes through it. Molecules such as hydrogen and carbon monoxide are excited by turbulent conditions and are heated to thousands of degrees to show up at these wavelengths. The James Webb Space Telescope's high resolution shows for the first time that the source is a double star, and this object, going across the bottom, is made from two jets. And that is the term of the month, Herbig-Haro. Back to you, Don.
Thanks, Stephen. We're back with John McGill, and we're talking about NASA's current asteroid missions. But we've also got an additional piece of information about an in-flight test coming up. John, what can you tell us about that?
Yeah, this was a special bonus we got, and it was a bonus for me. I got invited down to Starbase for the Starship, that's Elon Musk's big rocket down in Boca Chica, Texas. And so I went down there, and they call that Starbase.
Okay.
And here is the rocket garden that you can see from the road. So anybody can drive down this road, and this is what you'd see. And so I did this in black and white because I thought this was so reminiscent of Flash Gordon, back in the day, if anybody remembers that.
Oh, yeah, Flash Gordon. Like yeah, Flash Gordon, or that movie, The Day the Earth Stood Still.
Yeah, it looks like, it's from like the 30s or something.
For sure.
And this is what the actual picture looked like. So you can see the difference.
Oh, yeah.
But here, this was the launch of the Starship, and this is the biggest rocket ever made. This has 33 engines on it. And if this was the first picture I seen from my cameras that were at the launch pad, and I was so disappointed. I was thinking, oh man, I didn't focus my camera properly. This is all blurry. And when I went to the second image, it was like, wow, what's the difference? And it didn't dawn on me until after I looked at all of them that was actually the sound, the shock wave of sound hitting the cameras and shaking it so much.
Oh my.
So here's the one down in the lower left there. That's Arnold, and I name all the palm trees Arnold, for Arnold Palmer. But here you can see as the smoke and everything starts getting bigger and bigger and bigger until now we're all engulfed. And where we had these cameras set up during the first test, IFT-1, all these cameras got wiped out. Not one survived. The only thing that I heard survive was one guy's SD card. And those were the ones that were at the pad. And then I went to, after I got those set up, those were all remote control. And so then I went to South Padre Island, and there's a park at South Padre Island that we all met at, and it's about 4 to 5 miles from the launch pad. And so that's where I took these pictures. And they also had a picture, or not a picture, but a statue of Christ the Fisherman that was right at the end of the island. So I superimposed it with the rocket. And so that was just my postcard that I made up for this launch. But here's what the launch actually looked like from my vantage point. And so you can see just how massive the exhaust plume is from that rocket.
Oh, for sure.
And there you can see it going up. And here, this is my favorite picture of the launch. As you can see, there's like 33 dots. I call this the 33 candles. And the reason I say that is because the first launch, only 27 of them lit. So there was 6 that didn't light. So this picture shows them all lit up. And that's just a little clearer shot. And here we start seeing the rocket breaking the sound barrier, or what's called a vapor cone. And so you can see it starting at the top, and it's just getting bigger, and it's starting to go through it. And there you can see the halo or donut right by the exhaust. And this is another point where it goes through the atmosphere, and there's certain layers in the atmosphere where you get more of a vapor trail from the rocket. But this is a clean rocket. It burns methane. It's not the dirty kerosene. So the reason they use methane for this is because they figure when they can get to Mars that they will be able to make methane from what they have on Mars.
Okay.
And this was the big point where they had stage separation. So that's what that white is up on the top. So that's when the first, the booster separates from the upper stage.
Interesting.
And
John,
here you
in about the minute that we have remaining, what else can you tell us about this launch?
Okay, this is just going through, and this is the booster return, and this is, you can see it venting off a lot of fuel there. And this was the problem. And that was the big problem. It exploded or self-detonated.
The rapid
And
disassembly,
so
as they called it.
Just getting bigger and bigger, the explosion. And if you look here in the middle, this is like the center of the donut coming out. So as I go through a few more of these pictures, you can see it getting bigger and bigger and leaving.
Oh my, yeah.
And that was some pictures of the launch. And here was one in infrared. I just wanted to show this one. This one's cool. You'll see white things start coming out at you. And this was hot debris. And that one that just came by, that one hit the camera behind me. And so it put a big scratch in it.
Oh my. Oh, geez. It's a hazardous place to be.
There's the empty tower. So that was the end of my trip.
All right. Well, John, I want to thank you very much for being on the show today and sharing the news of the asteroid missions and this very interesting launch. If you would like to get more information, please check our website. And coming up to finish up the program, as always, is Stephen with What's Up in the Night Sky.
Thanks, Don. What's up in the night sky for January 2024? Now, we just had the solstice, and in the north, that's the winter solstice, so the days are getting longer in the north, shorter in the south, but they're getting they're changing slower near the solstice, speeding up toward the equinox. Now January starts with a third quarter moon on the 3rd, and a new moon on the 11th, first quarter on the 17th, and a full moon on the 25th. So then we have Mercury, Venus, and Mars shown on the 12th of January. Mercury goes from Ophiuchus to Sagittarius and rises an hour and a half before sunrise to 3/4 of an hour before sunrise. It's best at the beginning of the month. Max western elongation is on the 12th of January, which is, by coincidence, what the image is presenting. Venus is in Scorpius, going to Sagittarius over the month. It rises an hour before sunrise to an hour and 3/4 before sunrise, and it's best at the beginning of the month. Mars is in Sagittarius, rises 3/4 of an hour before sunrise to an hour before sunrise by the end of the month, and it is best at the end of the month. Now, then we have Uranus, Jupiter, Neptune, and Saturn shown here on January 1st. Uranus is in Aries, and it sets 4 hours before sunrise to 6 hours before sunrise. Jupiter is in Aries and sets 5 hours before sunrise to 7 hours before sunrise. Neptune is in Pisces and sets sunset plus 5 hours, so 5 hours after sunset to 3 hours after sunset. And Saturn is in Aquarius and sets 4 hours after sunset to 2 hours after sunset. And all 4 of these planets are best at the beginning of the month. Just a note about Pluto. Pluto goes from Sagittarius to Capricornus over the month, but it has superior conjunction on January 20th. And that's directly behind the Sun from us. And Pluto is pretty faint to begin with, so you won't be seeing Pluto in January. And that is what's up in the night sky for January 2024. Remember, we don't charge money for this show, but we may tax your brain.